Okay, I am going to go ahead and get started. We may have a few others still coming in, but wanted to welcome everyone out for our Advantage Kentucky Alliance Lunch and Learn webinar. And just so you know, we are recording today's presentation. So if you would like to have a copy of it or like to share it with someone, please let me know and I will pass on the link to that. I would like to just give you a brief introduction to Advantage Kentucky Alliance. We are the official representative of the Manufacturing Extension Partnership National Network here in Kentucky. We are focused on helping small and medium-sized manufacturers thrive in today's technology-driven economy. So we help our manufacturers become more globally competitive so that they can retain and even create additional industry and jobs within the state of Kentucky. So we offer expertise, training, and facilitated planning to help identify areas of improvement, streamline processes, and increase competitiveness and create new revenue streams for industries and businesses. So today our webinar is on total productive maintenance. Our presenter is Lawrence Clements. He holds a Master's of Science in Industrial and Systems Engineering, and he has over 35 years of experience assisting companies in aerospace, automotive, discrete and process manufacturing, utilities, mining, and flexible packaging industries. His experience includes project management in lean manufacturing, Six Sigma, operations improvement, production scheduling, and maintenance management. So please feel free to ask any questions that you might have. You can use the chat for questions or comments. We will be monitoring that. And again, we are recording this webinar so we can share that with you after. And I will now turn the time over to Larry for his presentation.
Okay, thanks very much. And what I'll do is I go through it. If you would put your questions on the chat box, and then I'll stop periodically, and I'll do a quick check with Kimberly and Stacy to see if there's any questions. So I don't want to wait till the end because I'd like to address questions when they're fresh. So let's see if I can get this screen to work. JD, did you get your sound to work? I didn't hear him. Maybe he hasn't yet. Okay, so let's talk about total productive maintenance and what it's all about. And the purpose of this discussion is, number one, it's an intro to what total productive maintenance is all about. And it's also trying to address some of the concerns that some folks had around the complexity of implementing a process like this. So we're going to talk about what it is. What is total productive maintenance? How do people define it? How does it fit into the concept of lean management? A process of how to implement TPM, where to start it, and a little bit about how to assess your readiness as an organization to pick this stuff up. So typical of plants that don't have an organized approach to maintenance, almost everyone I've seen over the years, you know, you can almost smell it when you walk in. Breakdowns are happening all the time. Very often there's a run to failure. Your operations people are constantly on the radio to get maintenance folks in there. In fact, if operations people have radios tied to their neck, like a lot of organizations do, when I walk in, that's typically one of the first signs that I look at. I say, well, if they have to call people on an emergency basis all the time, they probably don't have a well-organized system. And then nobody's tracking the losses, which is a big part of any kind of a maintenance system, whether it's TPM or anything else. And operators don't know enough about their equipment. Now, they live with that equipment 10, 12 hours a day, but they don't know enough because they haven't been trained properly on what to look for, what to listen to. So these are typical. So how does TPM address it? First of all, what is TPM? All right, it's a structured approach. Okay, it strives for perfect perfection. And the emphasis here on perfect means zero defects. Now, you'll never get there, but if you have a mentality of you're willing to compromise a certain way along, you'll never get to the best level you can. So it looks for zero unplanned equipment failures. Now, it doesn't say zero planned failures, but unplanned failures. Zero small stops, which means you may have cycles that have dwell times in them. Why do they have them in there? Are they significant? Can they be reduced? Zero defects from a quality standpoint. So no defects in the product as a result of maintenance issues. And then last, zero accidents from a safety standpoint. Not least, but extremely important, that we don't want to have situations where we are maintaining equipment in a dangerous method. The second piece of this is it's a collaborative process between operators, maintenance personnel, and management. We're going to take advantage of the fact that operators are standing at that machine or in that station 8, 10, 12 hours a day. They are there all the time. They know that machine. If we tell them how to look and listen, they know it better than anybody else. So let's take advantage of that. Now, what is it and what is it not? Okay, it's not a silver bullet. It is not a super maintenance specific policy. So if you're looking for a quick hit, TPM is not the way to go. What it is a culture, a philosophy, and a way of getting everybody on the same page on how to maintain all your equipment effectively. So everyone in the organization should be participating. Now, without TPM, typically, we've all seen situations where the maintenance department says, if it's not broke, we don't fix it, which is a typical run to failure mode. And I haven't run into companies in that mode in a long time, but there's a tendency to do that. And the operators, on the other hand, say, we run it. We don't deal with fixing it because that's outside our bailiwick. So there's the classical silos, and it misses the point where you've got resources that could be working this that are not. Okay, so with TPM, you have operations and maintenance working together, not only to coordinate when people are going to take equipment out so that maintenance can work on it, but also so that operators can have a little more ownership in their equipment. And when you have a little more ownership, people take a little more pride in their work. So you get everybody involved, and then you start reducing the classic losses that you tend to have because of poor maintained equipment. And what we're trying to do is understand what the condition of the equipment is in and get it back to a Class A level. What are the human errors and issues that we run into? And what is it that we don't know about the optimum conditions so that we can translate that into better controls, better operating procedures, and better training. So before I get further into this, any questions pop up so far? Okay. So this is a typical breakdown of where the time goes. If you have 24 hours in a day or 8 hours in a shift, this is typically what I have seen over the years in organizations that don't have a systematic approach to maintenance. 55% of the available time your equipment is running. That means 45% of the time it's down for something. It could be a changeover, it could be planned maintenance, unplanned maintenance, it could be quality losses. But what that says is you're losing over 3.5 hours out of an 8-hour day to downtime for some reason. Now, everybody can say, well, you have to change over. Yeah, but there's an efficient way to do it and an inefficient way to do it. Where does maintenance come in? Well, maintenance does come into changeovers because very often maintenance will have to repair or adjust something before you get to the changeover. Now, I'll give you a quick example. I worked with an organization several years ago where they were making molds of sintered tungsten. They were taking powdered tungsten, they were sintering it into a shape. So they had a mold, and they would fill the mold with powder, and then they would tamp it down tight before they would put it into an oven for sintering. And that tamping process was done in a fixture that was in a very much in a press. And we were doing a quick changeover assessment, and it was taking over an hour and a half to 2 hours to change out these dies, which really were only 4 bolts in, 4 bolts out. It shouldn't have taken any time at all. And what we discovered is that they would spend most of their time looking for not just tools, but also pieces of the mold, because they would share pieces of the mold with other molds. And sometimes they couldn't run a product because the piece was already being used. Sometimes the mold hadn't been repaired. And these are all maintenance and tool and die repairs. So you could significantly, in the case of certain kinds of changeovers, you can significantly reduce the downtime of the changeover if maintenance is scheduled properly in order to make sure the molds are repaired, or whatever tool is that you have to repair. So maintenance does have an impact in stuff outside of the maintenance department directly. But the key thing is, even when you're running, if you don't have a good program, only 40% of that 55% is actually producing good parts or good material, good product. Because you have things like, you have rate slowdowns. Sometimes you can't run the machine at its ideal rate or its standard rate because of some type of a maintenance issue, a wear on a part. You may have small stops, as I said before, which is nothing more than if there's a cycle. If you're producing a part every minute and a half or 2 minutes, and as part of that, you have to open up a die and drop out the part, that's a dwell time that you're not making the part. Well, sometimes you can adjust that so that it's a long dwell or it's a short dwell. And then other kinds of stops. So you're going to lose time for or quality, and you're going to lose certain kinds of parts for quality. So overall, it's very possible to be losing 4 to 5 hours a day per shift if you don't have an organized approach to maintenance. So that's what it's costing you, or what it could be costing you. So you know what we would do with a system after we put in TPM, we can see as much as 74% improvement in runtime. Overall, that means a 70% total available time versus 40%. So overall, we're talking 75% improvement in the process. Now, that doesn't say everybody would get that far, but that's the kind of improvement that we're looking at. So as we talk about some of the detractors, remember the size of the opportunity. It's huge. Now, I did some research for this, and simple on Wikipedia, it had what TPM is as a definition. It also had this statement about what are the disadvantages of total productive maintenance. And I thought it was very interesting. And I will let you read it, but basically what it says is, it's a time-consuming process, it's a challenge to implement, it's expensive, and it's complicated because of OEE and trying to manage the OEE and six significant losses components. Well, I disagree with that, because first of all, it is a time-consuming process. That is true if you do it right. It's a cultural change. So yes, it's a challenge. But anything that you do that's a major shift from the way you're doing things today requires time and effort. Is it expensive? It's an investment. You saw from the previous slide, we're talking about possibly a 75% improvement in the capacity. That's huge. That says if you're running 5 days a week, you only really need to run 3. Or if you're running 2 shifts, you really only need to run 1. Think about the implication of cost by eliminating a shift or eliminating a day from your production cycle. Or on the other side, figure out how much more product you could make if you're sold out, that you could sell 75% more product. Yes, about 70% more product from the extra production capacity. So is it expensive? Well, it depends. If you're not getting the result because you implemented it improperly, yes, it is expensive. But if you implement it right, then it becomes an investment that has huge payoffs. And then as far as measurement, in this day and age, you have to measure. And I've had people tell me, what measured gets done. So you have to have a measurement in place. Do you have to have OEE? Well, that's debatable. There are other ways to measure at the beginning to get you started. If OEE is something that it's too big for your organization. So why do we stall? Well, it's lack of management commitment and lack of understanding. If management is looking for a silver bullet, this is not the way to go. In fact, most cultural changes, even things like doing 5S, it requires a commitment of management in order to make it happen and make it keep happening. Shortcutting the process. If you jump into this too far down the line and don't put the basic building blocks in place, you are going to have less than satisfactory results. You can't really shortcut the process. And then incomplete follow-up. I've walked into so many organizations where they put something in place, 3 years later, it's half or 3/4 fallen apart. There's a follow-up audit process that is involved no matter what, whether it's TPM or anything else. If you're making a change, you need to be sure that the organization has stayed on the path. And you have to have an audit process in order to be able to do that. And that's one of the big things that I've seen that causes failure in TPM and any other major system we have. So the case comes down to either manage it or be managed. So I would say if you want to implement TPM, there's some ways to do it that makes it relatively simple, but it is a commitment that we have to make in order to make the change. But there's a huge payoff at the end of the road. So let's talk about TPM from the original 8 pillars. The Japanese like to build these houses. It seems like every process they use, they have a little house with a foundation and pillars. So we'll use their model. And basically TPM is based on doing 5S because it's a good process to clean the equipment. It's a good process to set up organization. It's a good process to set up a discipline of working with your equipment. And then some of the steps, the first thing we want to talk about is planned maintenance. Because if you have a system for planning and scheduling your maintenance, you're much more likely to be able to make things change. We want to talk about autonomous maintenance, which is simply having operators do certain maintenance tasks. Early equipment management, and you read that as preventive maintenance, PMs. Do we have a solid PM program in place and are we following it? Focused improvement, which is similar to continuous improvement, but are we focusing on the critical issues? Here's where managing your data comes into account. And if you set up charting of your major losses, focus on the major losses first. Do we have a quality component? Health, safety, and environment. Are we looking at maintenance from a safety perspective? Do we have a training program to train our operators and our maintenance folks in terms of how to operate in the new system? And then do we have awareness and training for our administrative folks who may often have bigger impact on maintenance because of the way they choose to prioritize and spend money? For the purposes of today, I want to focus on planned maintenance, autonomous maintenance, and early management or early equipment management as where we want to look at to start. Again, another house from the Japanese quality improvement process, continuous improvement. And if you notice here on this continuous improvement house, TPM is way up in the left-hand corner. And what that means is it is not the first program you should implement if you're going down the road of lean. Okay, what you want to have a 5S system in place. You want to have some understanding what visual controls are, standardized work, and quality at the source. Those concepts should be understood by your organization before you delve deeply into TPM. So you want to go up this path to establish yourself a good base before you get serious about total productive maintenance. That's not to say you can't do some of the things in the meantime, but you want to have these things in place and working to a certain extent before you challenge the TPM process completely. How does it work against the 8 elements of loss? And this is our classical 8 waste downtime. Well, from a maintenance standpoint, defects consist of literally defects that are caused due to poor maintenance. You may have process variability that creates product that are out of tolerance. Overproduction is, poor planning and scheduling and misprioritized work. And a quick example of that, I worked with a client several years ago. I was handling some of their operational tasks and training folks in managing on the production floor, and maintenance was part of my responsibility. And sitting in the office one morning, the owner of the company comes walking in, very upset, showed me on his phone where he had taken a video of the steam vents up on the roof. One of the safety valves had tripped, and we were venting steam up into the atmosphere. And he said, "Do you know how much this is costing me?" And I said, "No, do you?" He said, "Yes, it's costing us $5,000 a month to have this steam vented up the roof." He said, "Why isn't a maintenance guy working on it right now?" I said, "Well, they're working on fixing the dies for the next changeover on our equipment. We change over each piece of equipment 3 or 4 times a week. Every time we change over, it costs us $4,000. If the material isn't prepared, if the dies aren't taken care of and cleaned, it adds another $2,000 to $3,000 for every changeover. So what's the priority that we want to deal with? You know, if I'm losing $5,000 a month for a few days on a steam vent that is not affecting production versus $2,000 or $3,000 a day on production equipment that is going to keep us from getting product to customers, which do I do first? So that's an example of, do we have a common understanding of priorities and a structure for doing priorities and a scheduling process? And waiting comes down to, and I have maintenance waits on production for release of equipment, but it could go the other way. The piece of equipment goes down, or it was scheduled to go down because we're going to have maintenance and maintenance doesn't show up. Non-utilized talent, which is the whole point of what we're talking about today. We're missing the opportunity of utilizing operator talent to help us with the maintenance process. Transportation, expedited freight. I mean, when a piece of equipment goes down unexpected, do you have the right parts in the warehouse in order to be able to fix it? The odds are pretty good that you don't. Inventory, on the other side of that, is if you've been burned before, you're probably going to have more inventory than you really need, because you'll want to have that piece, that part that failed, just in case it fails again. Motion is repetitive trips by the maintenance folks going out to a location to, first of all, once it goes down, they have to assess the situation. Then they have to figure out what they're going to do. Then they have to go back to the warehouse to pick up the parts, pick up the tools, and then go back out. You may go out 4 or 5 times because we didn't have it well organized. Excessive processing is utilizing high-paid maintenance techs to do simple maintenance functions that can be done by an operator. So there are cost factors in there. So there's a direct relationship to lean within the maintenance program. Let me stop right here just for a second, see if there's any questions that have popped up on our list.
Lawrence, I do have a question. You had mentioned 5S,
yeah.
And I know that's one of the bases, but can the TPM program be started if the 5S program is not yet in place?
5 years ago, I would have said yes. Today, I would say, if you're going to start it, start your 5S in the area where you want to first do a small project of maintenance, because cleaning the equipment is critical, and we'll get into this in a couple of steps. But having clean equipment and having that equipment at, I'm not going to say a total Class A level, but at a level of operating capability that you can set as a standard is important. And 5S helps organize that. The reason we say 5S comes first is partly because of the mindset that it starts to create in people. 5S is a relatively easy thing to do. People understand housekeeping. People understand organizing tools. They understand keeping the place neat and orderly. And they also feel good once you clean up the equipment. They get some pride in it. So by having that first, you start the path down cultural change. And that's the real value of the 5S, or one of the values of 5S. The other one is, it's a heck of a lot easier to work on clean equipment than it is to work on dirty equipment. I hope that answers that question. So let's move on a little bit here. And let's talk about these three elements in more detail. Here's my answer to 5S, okay? It organizes, it cleans, and it shines. And we'll talk, and I'll show you some examples of that. Visual controls, okay? It's a lot easier, especially in multicultural, multi-language workforces. Using visual controls helps communicate what you want very easily. It simplifies the communications, and it sets, if it's done properly, it sets people to move in the right direction. And then planning and scheduling is, do you have work orders? I have walked into many organizations in the last 10 years where they have what we call the yell system, which is the maintenance people is needed. I yell on the phone, I need somebody. We need to have work orders in our system and what we call a work order process to be able to document what the problem is and document what I'm going to do about it, so that if it happens again, I've got a record of what I did. It also helps in terms of establishing how I'm going to collect my data so that I can see where my biggest downtime issues are. So work orders is critical to the basics. Prioritization of work. Do I have a standard way to prioritize my needs for maintenance that everybody in the plant understands? Okay, how do I prioritize customer-related issues versus non-customer-related issues? How do I prioritize safety issues versus production issues? We need to be doing it the same way throughout the organization and agree that we do it at the same rate. Otherwise, you have a jumble of things, and it makes it difficult. And then controlled scheduling. You have resources, and you have a limited number of resources that you're working with in the maintenance department. How are they best being deployed, and are they being deployed in an organized way so that you're spending most of your time turning wrenches and and as minimum time searching for parts, tools, and things like that? So here we go. If I didn't do a 5S, this is a picture of a power transfer. That's a coupling, and you can see where the operator's finger is pointing. That's supposed to be a bolt there. Okay, there are 8 bolts that hold this universal joint on. That one's missing. You can't quite see it because it's so dirty. That bolt is about ready to fall out. So what we want to do is clean up the equipment as part of a 5S program leading into TPM so that I can see what's wrong. I want to be able to fix this so that it can be fixed in the future. So that's why you do the 5S. Now you can do it on a broad plant basis, or you could do it focused on that piece of equipment, but you need to do the 5S concept as part of your basics. Okay, autonomous maintenance is the next area. And these are operator managed tasks. Okay, so you need to be able to document what the maintenance activities are and then decide who's going to do them, the maintenance people or the operator. And then you need to train the operators and certify that they can do the kinds of things that you want them to do. So now let's go back to our joint. We've cleaned it up. Looks a lot better. All the bolts are in place. We've also done one extra thing to help, because I'm going to ask my operators now to tell me if those bolts are loose. You see these little marks? Those are not reflections because of the camera. Those are called witness marks. It's a piece, it's white paint that maintenance put there when they tightened the bolt and torqued it to whatever tension that they needed. They drew a line that goes between the bolt and the boss. So as long as the paint is lined up, we know that that bolt is tight and tight to the extent that it's supposed to be. If that bolt starts to twist, those lines aren't going to line up. If I tell the operator, I want you to, on a certain frequency, look at that and go to a checklist and say, yep, they are or they aren't, I have now probably eliminated the potential to have variation and shuddering and chatter on that unit, because the minute we start to see it, they can call maintenance, and maintenance can come over in a non-emergency method and come in and tighten those things up. Very, very simple. And that's a classic view of autonomous maintenance. Okay, early equipment management is preventive maintenance, for lack of a better word. Every piece of equipment requires a certain amount of preventive maintenance. You need to grease the bearings, You need to tighten up the bolts. You need to change filters, certain things on a repetitive basis. So we need to have some type of a program that identifies when we need to do it, how much time it takes to do it, and what needs to be done. So we need to document all of our PMs. We need to have an annual schedule for the plant so that I can schedule all these so they don't come on top of each other. Several organizations will have, or several types of material will have weekly, monthly, quarterly, and annual preventive maintenance. Well, if you don't have it all laid out, you may find out that you're doing your quarterlies at the same time you're doing your annual. And you're doing several pieces of equipment at the same time, and you overrun the capability of your organization to do it. So to have some type of an overall annual plan to watch. And then downtime tracking. If we're running at 55% uptime, the rest of the time is downtime. Where's it going? And we want to be able to track that on a regular basis so we can identify where the big hitters are. And when we do better, we ought to be able to see a reduction in that. So we should be able to track our progress. Tracking the downtime information is probably, next to doing a 5S, is the number one thing that you need to do to know that you're moving in the right direction. Now, everybody says, you know, planning and scheduling systems are big, expensive, and I have a small organization. And I agree. If you go to one of the big IT programs, you can spend $5,000, $10,000, $25,000 on a planning and scheduling process. This that I put up here is an example of a spreadsheet, an Excel spreadsheet planning system that we established for a company about 25 years ago. They operated with 50 maintenance people with this particular simple spreadsheet. And you can use a simple program like this for anywhere from 2 people to about 50 people. And the investment is training your maintenance supervisor or planner for about a week on how to use it, and then monitor it for about 4 weeks to make sure that it gets implemented well. Underlying it, though, you need to have a work order process so that you know what to be putting into the blanks. The way it's set up is you have a labor supply. You have so many people of different crafts, and each craft needs to identify how many hours a week are these people identified. And this is something that supervisors should be able to tell you 1 to 2 weeks in advance. Then you have all the tasks. You have a backlog of maintenance if you have work orders. So what you do is take each work order, and each work order should have an estimate of how many hours we think it's going to take, and you just put them down for the week and identify the hours that you need in each particular category. Then the spreadsheet will tell you whether you're over or understaffed, because it's going to tell you right at the beginning how many hours it's going to add up how many hours you've assigned. Also, once you've completed it, you come down here and enter in who completed what, and it will automatically tell you your basic KPIs like schedule attainment. What percentage of the work did we get done? How good were our estimates? How much was planned? How much was unplanned? And it does it very, very simply. And you can link it simply to a set of charts, and you can trend your progress over time. And it's a very simple process, saves you thousands of dollars in IT implementation, which what I found is even in large organizations like General Motors, they spent tens, if not hundreds of thousands of dollars on very sophisticated maintenance management systems. And in several plants that I was at, the only thing that they were using them for was to document work orders. They weren't using any of the other sophisticated processes that were in there that they paid for, but was well beyond the capability of the organization to deal with. This is a very simple process. Everybody can understand it, and it's very, very easy to manage. So that's planning and scheduling. That should be one of the early things that that you put in place. Now let's look how they work together in a case study. All right, this is a picture of an automotive assembly plant, and this is a welding and small part assembly station. And if you look, and I apologize for the blurriness, but I couldn't blow the picture up any larger without losing some of the granularity. But there are 8, if you count them, there are 8 orange weld and assembly robots. Now, robots are great because they don't take breaks. They don't have to be paid overtime, but they do need to have maintenance. These robots had to be greased and lubed and cleaned on a regular basis. Here's our PM. So These are the things that have to be done to each machine. And this is what I call, standardized work for this particular operation. So each machine had to have certain things done to it, how long it takes, and the interval. This is classic. This is good stuff. Here's our lubrication process. Okay, so we're going to lubricate machines. I got daily, weekly, and monthly lubrication tasks I have to do. Now the operator, we call this training, this a 1-point lesson. This is something very, very basic if you're going to have operators, and even if you have sophisticated maintenance people do things, that you want to be able to describe visually. Here's what, when I say grease the bearing, this is what I mean. You take a grease gun, you connect it to the nipple, and you have 1 squirt of grease. A lot of people will put in more squirts simply because if a little bit is good, a lot's got to be better. Well, it's not just the waste of the grease. Some bearings will not perform well if you over grease them or over lubricate them. So you want to have the right amount. You also want to have the right kind of grease to go in there, and that's part of the description. But this is a 1-point lesson, and I want to give you a quick story of an actual situation, because a lot of people will say, geez, everybody knows to do that. Well, no, everybody doesn't know to do that. Again, working with a large automotive company, we were doing a maintenance planning process, and we were laying out a PM structure like this. And it got down to the point where we described the process to fix things. We also described the tools you need. And we said, you need a slotted screwdriver in order to be able to perform this task. The maintenance people were incensed that, and insulted that we said, we have to tell specific, not specific, but sophisticated maintenance techs that they had to use a slotted screwdriver. I said, really? How big is this plant? And I forgot, it was like several hundred acres, which means a maintenance person could go and be gone for an hour just to walk from one location, from the maintenance shack all the way to where he had to fix something. But what happens if he didn't have that screwdriver? He walked all the way out there, no screwdriver. So what we did was say, all right, guys, stop the presentation. We all walked down to the maintenance shop. Guys, open up your toolboxes. There were 20 maintenance guys down there. 10 of the 20 toolboxes did not have a slotted screwdriver in their toolbox. Well, what if I picked one of you guys that didn't have the screwdriver to go fix that part that I have way on the other side of the plant? I'd be getting a call, hey, I need a screwdriver, and I'd send somebody else to get you, or you'd have to come back. We've wasted all that time. That's why we keep things simple. So now you have a checklist to minimize those kinds of errors. It's not a case of not trusting. It's a case of double check. Pilots do this all the time. Regardless of how many hours a pilot has in a flight, you have a check-off checklist that you go through to make sure everything is done right, because you don't want to have a failure in the process of taking off the airplane. Same thing here. So you want to communicate. You typically would have this reside right there where you're going to be fixing or taking care of the machine. You might have a separate copy back in the maintenance shop so that you have bits of people who do research. And it's something that can be referred to by the operator, especially when we're talking about autonomous maintenance. So now let's go back to our lubrication standards. There's a $28,000 failure on that sheet that you probably won't pick up unless I really show you. And let me explain the process. That plant runs 24/7. It runs 1,500 units a day. That's 1,500 cars coming off the end of the line finished a day. That's 1 car a minute. Each car contributes $10,000 to the plant. So that's basically, you look at it as their profit. So every minute of downtime is expensive. Every minute of downtime costs $10,000. So you got this operation right here, which basically says every day I have to, for every one of those robots, I have to go in and check the oil pump and refill it if necessary. That takes me 3 minutes. Let's go back on site. One of the downsides of robots is they're very unfriendly around people. That robot doesn't know that you're there, and if it's turning through, it's going to knock right through you, and steel and flesh don't work well together. That's why they have all those yellow cages around there. So what happens is if you're going to oil that machine, you've got to go to the pedestal on that machine, which I don't know if you can see my little arrow, but that's the pedestal. Okay, the oil fill is right in here somewhere. So in order to do that safely, what do I have to do? I have to lock out and tag out this entire section, shut the plant down, and then I can go in there and I can do my oil checks. All right, well, I need 3 minutes for each one. Well, there's 8 machines. So either I send one person in there for 24 minutes or 8 people in there for 3 minutes. Both ways, I'm down for several minutes. It also took me 3 to 5 minutes to do the lockout tag out. So I'm down for anywhere from 3 to 28 to 30 minutes where I could be producing cars. So let's say it's 30. That's 30 cars that I lost at $10,000 a piece. That's $300,000 losing what did we say back here? Every day. That's a lot of production for a 3-minute oil change. So there's a lot of opportunity there. Now, granted, this is a high volume, and it may not apply to some operations, but that's a high volume, simple solution. And what do we do? Well, you separate things out. And what we did was basically run lines from the equipment to outside the cages, and we made the oil check. We put a gauge and a filler nipple outside the line so the operator could just walk along without ever stopping the machine and do his check and fill the oil tank as necessary, or the oil pump as necessary. That way we had it done. We didn't have to worry about coordinating time of day. We didn't have to worry about people missing things because, well, we're under production, so we don't want to shut it down because we're running so well. You could continue running, you separated it, and it was safe. That's how you address some of the problems you have, and that's part of the autonomous maintenance. That's part of TPM as you move forward. Any questions before I move on?
Larry, just to let you know, we have about 5 minutes.
Okay, so I've got about 3 or 4 slides, so we're close.
Good, all right.
Okay, so visual controls, these are some examples of visual controls. And if you take a look up in the left, okay, that's good. Okay, that's a gauge. That tells the operator or someone, okay, we have some pressure that or something that we're measuring, but it doesn't tell you good or bad. Okay, this one's better because it actually tells you what the good range is, what the bad range is. Even better if it told you what to do if it goes outside the good range. But you want your visual control to tell you something and to initiate behavior. Down here, what that little stick is telling us is that we're running right at the bottom of the tolerance level, and we probably should adjust it. And back here, which is right in the middle, so we're good to go. Very, very simple, something that an operator can do that normally a maintenance guy might do. So these are classic examples of how do you get what the information that you want to the operator so that he can do something. And maybe all he does is call the maintenance guy to say, okay, you need to come over here and tighten this chain. But if he didn't do that, we could run that chain right off, or we're running maybe slow because the chain is too loose. And we eliminate some of the possibilities of problems. But these are examples of what we mean by visual controls. Tools are another thing. Do your operators have, once you've given them the challenge of autonomous maintenance, do they have the right tools? And do we know that the tools are there? Small tools disappearing on the shop floor is very, very common. So we need to have something that we can audit to make sure that whatever tools we told them they need to have are where they are so that we have confidence that we can get the job done. And then the last part of this is implementation. How do you implement an overall TPM process? Well, the first thing you do, we have to get management to communicate the vision and the plan. Part of that is so that the organization is aware, but part of it is also that management needs to understand what they are committing to. That this is not a one-day program. This could be a 2 or 3 year investment. And you want to be sure that management is committed for that before you go full bore. The other side is charter an interdisciplinary team in order to make it happen. You don't bring this as just a maintenance project or an operations project. This is a plant project that everybody collaborates in. So you want to have different eyes, different perspectives looking at it. Then you can start by identifying a pilot area and conduct your 5S. If you haven't conducted the 5S plant-wide, conduct it at least in that pilot area so that you clean up the equipment. Then you want to identify operator tasks from your list of PMs, and you want to add some visual controls. Then you want to identify what are the KPIs, critical process or critical performance indicators that you want to have, and set up a visual activity board so that everybody can see what's going on out there. And I've got one last slide on that I'll show when we're done with this. And you want to start measuring. Now, whether you measure OEE, which is overall equipment effectiveness, or you measure just downtime, I would suggest that you start by just measuring and organizing downtime and uptime. It's simpler to do. It's easier to understand because you don't have, it's not alien to the plant. Most people understand uptime and downtime. And it'll get you probably 75, 80% of the way there. So as you're addressing issues, you want to start structuring your planning and scheduling. Get a work order system in place. Start prioritizing the work, and then have somebody organizing the labor so that you can get the work done in an orderly fashion. And then have regular communication. The visual board outside your pilot area is one part. You need to have regular communication with with management to make sure that everybody is up to speed and on the same page. And then lastly, you want to celebrate your successes. Even small ones, you want to celebrate because you want to recognize that the team is doing work, and you want to recognize that it's important. And it communicates to the rest of the organization that this is good stuff and it's coming your way. Just a quick view of what a visual activity board is, and it's nothing but a large board that you would have out in the area that has critical information on it so that anybody walking by can see the status of the process, who the team is that's working on it, what kind of data. Here it's OEE data, but it could be simple uptime, downtime. It could be pictures of the improvement. Typically, I put in the before and the after. I take pictures of what the place looks like before we started, and pictures of progress and pictures of after, so people can actually see how big the changes are. What your project goals are and where we are against those, what the failure modes that we're looking at, how much time is lost in various issues, how the results are, and then any kind of next steps or activities that the team is working on. Keeps everybody in the loop. You can actually, look up, there's several different ways to set this up. So if you just Google it, and you'll find out all kinds of different ways people have used activity boards. And then lastly, other considerations, I just want to reinforce that everybody has to be involved. This is not a maintenance program. This is not a operations program. This is a plant program that addresses uptime. Then the last, to close this out, quick assessment, are you ready to do TPM? Well, if you're plant-wide in all of these issues, yes, you are. Okay, if you've only done one, but have started in some of the others, and the thing is that people need to be aware of what they are. The biggest change issue is people's awareness and how comfortable they are with these new concepts. So if you've only done the 5S program, yeah, you can do pieces of the rest of the TPM program and start getting that at work. If you're still at the discussion stage or you haven't thought about it at all, it's probably not where you want to start. You probably want to start with your 5S program and get some help and work in some of the others, working your way up the line. So that's basically it. So we have any questions that popped up in the meantime?
Yes, we do. JD just asked, let's see. My experience has been getting planning and scheduling involved. Would you agree?
Planning and scheduling is a critical part of keeping everything organized and flowing, because what you want is less than 5% of the time spent fixing things or working on maintenance should be on emergencies. The only way to do that is to plan and schedule and make sure that your PMs are done. And you need to have a planning and scheduling effort focused on that. You'll get a huge bang for the buck just by putting some good planning and scheduling process in place. But you also need to have prioritization of work to go along with that, because it's fine to plan and schedule, but if you're constantly not doing the work that's on the schedule because somebody says this is more important, that's an indication that you don't have consistent understanding of what the priorities are.
Larry, I have a question. If I were wanting to get started implementing TPM, where would I start? And does Advantage Kentucky Alliance have a service that can help me get started?
Yeah, we have TPM experts and maintenance experts that can come in and do an assessment of your plant, and give you an idea of where you might want to start from a process standpoint. From a physical standpoint, I would take a look at, and this is just off the top of my head, if you have a linear process, what's either your bottleneck step in the process or the first process? Because either one can be a major headache if they're not functioning properly. If you don't have any kind of downtime recording, I would start there. If you do have some type of downtime recording, I would take a look at what are my biggest, what we call bad actors. Which machines or which process steps are causing the most downtime, and start in those locations. And I wouldn't take the whole plant at once. I'd take it in small chunks.
We have another question in the chat. Dave asks, what would be a typical amount of time operators would spend on TPM tasks per shift?
Anywhere from 5 minutes to 20 minutes. And most of the time operators have that kind of time in there. There are very few that are so tight that they can't do. And we're not talking about fixing things. We're not talking about picking up a wrench and tightening up nuts and bolts. We're talking about the kinds of things like I showed in that universal joint. You do a quick observation, and basically write it down. The biggest objection I get with the idea of operator maintenance is that we're asking operators to fill out a checklist. Operators and a lot of people on the shop floor just don't like to do paperwork. That's the biggest obstacle I've run into. When they find out that what they're doing actually keeps their machines running, so they don't have the frustrations every day of ups and downs, it becomes a lot easier. There's something in it for them. But maybe 5 minutes to 10 minutes of observation and monitoring. Some of it is they're looking at the machine anyway, and if the gauges are right there in front of them, they're looking at it just as part of what they're doing.
There's another question from JD. I'm trying to read this properly. My experience for heavily dependent machine operations start with 5S, quick changeover, then TPM, and that's the question. Your critique. We've never had an operator remove a guard.
Well, the sequence is right. You want to start with 5S, so you work your way up the house of lean. TPM should be, as one of the last things that we get to. It's the most sophisticated. And I agree. Operators should not remove guards. That's my example of the lubrication on the robots. You don't want operators removing guards. The guard is there to keep the operator away from moving parts. And you can actually say, I'm just thinking right now, you could actually say that's one of the checks. If the operator has to remove the guard to do the work, you probably don't want the operator doing it. But that doesn't necessarily mean you don't do it, right? If you take a look at that example, we said, how do we do it without shutting the machine down, without shutting the robots down? We separate the task from the dangerous situation. So whatever it is we wanted him to open the guard to take a look at, can we move it outside the guard so that the operator can do it from outside the guard in a safe environment?
We are running short on time, so we have one last question. Would detailed equipment cleaning be done by operators during planned shutdowns?
Yes. That's if you have the kind of a process where you run it every day and then have a plant shutdown once a month or once a year, yes, you want operators involved. In a 5S program, you would have operators involved, you had maintenance involved, you'd actually have management involved. For those of you that have gone through a 5S Kaizen, we typically get a group, a cross-sectional group like that, and I've actually had vice presidents on their hands and knees scrubbing the floor to help clean the place. It does a lot of things. It shows the commitment of management. It also shows management what it takes to keep the place clean, and it provides a good camaraderie and team building.
Okay, thank you. Thank you, Larry. Is there anything else you want to say before we conclude?
No, other than it's a journey that's well taken, because there are tremendous benefits at the end of the line. You not just in cost, but you also get a much higher level of morale in the organization, because you've got clean equipment that functions. And there's nothing an operator hates more than having to fight a piece of equipment over the course of his or her shift. They like to run, and they like to run smoothly.
Okay. Thank you. Thank you for your presentation today. We'd like to just finish, close up by letting you know of a couple of upcoming events. We have on January 4th is our next webinar, the first of the for 2021, and it is on advanced manufacturing industry 4.0. And then we also have, starting in January, so it's January 28th, our Lean Six Sigma Green Belt training. It's a workshop, a period of classes, or a series of classes. You can find more information on both of these and other upcoming events on our website, and that is advantageky.org. And you can go to the events page and find out more information and register for any of those. And I will be sending out a survey this afternoon about this webinar. If you have any further questions, you want more information, you want any other information on this topic, you can just add it into that survey, and we will be happy to answer those questions. So I want to thank everyone for your time today, and hope everyone has a great afternoon. Thank you.